Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the November 2023 IB Mathematics AAHL Paper 1 examination. This is a 7-mark question on mathematical induction. Let's get started. Mathematical induction is one of those topics that many students dislike and many times get wrong during the test. But it doesn't need to be hard, and actually it's very easy to solve if you get the method down right. There are only really 3 types of mathematical inductions, of which I will cover one today and I'll cover the other 2 in a later video. So just follow along and hopefully by the end of this your doubts will be cleared. So the first step to solving a mathematical induction problem is having a piece of 1 where n is equal to 1. This is my basis for the overall proof. If this doesn't work, the overall proof doesn't work. Let me substitute n is equal to 1 into this right there. So 5 times 2 minus 2 times 3 is equal to what? I need to show that whatever is equal to is divisible by 17. So 25 minus 8, which is equal to 17, which is divisible by 17. So piece of 1 holds true. Okay, now piece of k. As piece of 1 is true, and assuming piece of k is true, we then set up the second part of the proof, where we substitute k into this equation. So 5 to the power of 2k minus 2 to the power of 3k, and that must be equal to 17 times some integer a. A is some integer. Okay, that's the whole thing I want to prove. I want to prove that whatever is equal to is a factor of 17, is divisible by 17. So that's what I'm going to prove. Now let's go to our final part, piece of k plus 1, the most difficult part of a proof. So how do I do this? First, I need to substitute k plus 1 where n is equal, wherever there is n. So n is equal to k plus 1. So let's do this. 5 to the power of 5 to the power of 2 into k plus 1 minus 2 to the power of 3 into k plus 1. Okay, let's get started. And that's equal to something. Alright, so first let's use our exponent rules and expand this. So we get 5 to the power of 2k times by 5 to the power of 2, which is just 25, okay, minus 2 to the power of 3k times by 2 to the power of 3, which is just 8. Now what do we do from here? How do I prove that this is equal to something that's divisible by 17? Now look at the second step, piece of k step. I said that 5 to the power of 2k minus 2 to the power of 3k is equal to 17a. Now what if I just rearrange this into something I can use? What if I say that 5 to the power of 2k is equal to 17a plus 2 to the power of 3k, right? Can I not say that? That is something that I proved earlier. So let's use that. Let's substitute this for 5 to the power of 2k in the piece of k plus 1 step. So 17a plus 2 to the power of 3k times by 25 minus 2 to the 8 minus 8 times 2 to the power of 3k. Now let's expand this out. 25 times 17a plus 25 times 2 to the power of 3k minus 8 times 2 to the power of 3k. Now look right here. Can I not simplify these two terms? Because 25 minus 8, right? So I can rewrite this as 25 into 17a plus 17 times 2 to the power of 3k, right? All I did was 25 minus 8 into 2 to the power of 3k, right? That's the simple exponential rule. Now, what can I do here? Well, I can take 17 common. So I'm left with 25a plus 2 to the power of 3k, right? And does that not prove that whatever I have in the inside is divisible by 17? So, where this is an integer. Okay, so hence I've proved that 5 to the power of 2n minus 2 to the power of 3n is divisible by 17. So I will copy paste the final statement for a mathematical induction, which is here. Since piece of 1 is true and piece of k plus 1 is true whenever piece of k is true by the principle of mathematical induction, piece of n is true for n is part of z plus. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.